Hello everyone, welcome back to the channel. So today is our third video of our Semantic Kernel Learning AI video series. And in the last two videos, we talked about how to set up your Semantic Kernel environment. And in the second video, we talked about how you can create prompts, and with prompts, how effectively you can do a prompt engineering to make your services more intelligent. And in this video, we are going to learn about plugins, and we'll be talking about built-in plugins, and as well as we'll create our custom plugin. And in previous video, we took example of applying leaf for leaf prompts, and this one, in this example, in this video, we are going to create one custom plugin, and we'll be calling that plugin from our AI service, the LLMs, so that it can create a request based on the past prompt. So let's get started. So what are plugins? Plugins are actually a key component for semantic kernel, where you can encapsulate all your existing traditional code APIs into one existing set and can be called by an AI to do the more contextual operations. So for example, if you want to ask AI or LLM model that what is current time, so you would not get any result out of it. It will say like it's not having the real-time information. So for that, you have to have some plugins in place which can execute few lines of code for you and give in turn the result, the contextual result which you are looking for. So those are the plugins. So let's get started. I'll just open my Visual Studio. And lastly, I told you how you can initialize or create builders and then create kernels out of it. And later on with kernel, we are going to directly work today to add the plugins. So right now I have just installed one NuGet package, that is Microsoft Semantic Kernel plugins. And this one, once you install this one, you would be allowed to create or use the built-in plugins. So we are going to take example of built-in plugin of time. So we can search about like what inbuilt plugins we have. So here we have full list of built-in plugins which comes with the Semantic Kernel SDK. So you can see we have this file input IO operations, HTTP plugin, math plugin, text time plugin. So these are inbuilt plugin we can directly add from these plugin types, and which we have already imported in. So we have used this Microsoft Semantic Kernel plugins, and while doing this builder, we can start adding these plugins. Add plugins dot add from, and we can add the plugins from object, from type, and as well as from importing some files. So we'll be doing it from type, so because we have already this time plugin, and we'll do this time plugin, and post that we'll be just creating our instance of kernel builder dot build, and lately then we'll just invoke this one, and we'll kernel dot invoke, and we'll be passing the plugin name, and that is our time plugin, and we'll be calling the method of the plugin. So we can say it should give us this week of the day. So the function name is day of week. So once we invoke this one, and we'll capture that into our result variable so that we can directly write it on our console. So we'll just say, and it's a sync call, so we have to do await console dot write line, and we'll be writing this result. So we are going to invoke the inbuilt plugin right now, and we'll just run it for once. So it ran, it invoked our plugin method, and it gave us a result as Sunday. Today is Sunday. So it works fine. But now the question comes, why we are just invoking directly? Like, because the actual meaning of having these plugins in place, like when our natural language input should be processed in the same way as we directly invoke this method. So for that, we will be using, instead of this invoke async, we'll be using invoke prompt async. And in the prompt, we'll be passing the the prompt, and that prompt should be precise so that it can invoke the method, which is method of day of week of time plugin. So what we are going to do, we are going to create the prompt execution settings first of all, and we'll say settings equal to new settings, and over here we'll be specifying the function calling behavior. That means that we are going to tell that the AI service should invoke the right method automatically. So we'll just say function behavior dot auto, so that it should automatically invoke the method, the right method based on our past prompt from this plugin. So we created this setting, and this setting we are going to in turn use into our this await kernel dot invoke prompt async. So over here we'll be passing the prompt, give me, please provide me current time in UAE, and we are going to invoke this plugin method of get current time automatically. So we should not be passing any method name, but it should use this plugin to serve us the current time. And we'll be saying new kernel argument, and we'll be passing this setting which we created to auto invoke the method, and the same behavior would be invoked served when we directly invoke this method. And when we are going to render this or show this on our screen, we should get the current time. So we'll just run this invoke prompt async, and we'll just see what output we are getting. So on invoking, we got this time Sunday 17 November and the time in UTC format. So that's how we can invoke this plugins, the inbuilt plugins, using prompts by directly providing what exact information we are looking out, and with the function joins behavior auto, it will auto invoke, it will smart enough to recognize what context we are passing in prompt and will result. And there is another way of doing it, like when we want that it should not auto invoke, it should actually look for a specific method. So there we'll be just saying, we'll be passing our function name. For example, we have these functions, and over here we'll be just creating our function name over here, and in the function before that we have to get the function out of our kernel. So for getting that function, so we'll be just saying kernel function, and let's say get time function name, and we'll be just taking this from kernel dot plugins dot get function, and we'll be passing the function name from the first of all this plugin name, and then second argument it takes this time. So we'll just say the method name. So we'll say UTC now is our method name. So this will give us this get time function, and over here we can specify that function so that it will only look for this function get time instead of like auto invoking or looking for another functions. So this is the another way of specifying which particular function this prompt execution setting should look for, instead if you just don't want to look for auto one. So this is with inbuilt plugin. We just had an example. So as I said, like we'll be working more on to, I'll just remove everything, creating a custom plugin. And last time we took example of leaves, so we'll just continue with our last example of leaves. So I have just created one class leaves. This class is basically will do operation of creating leaf using HTTP calls, and as you can see, like I have actually creating the leaves into my SharePoint list. So I have one list which will act as my this leave repository where all the leave requests would save. And I'm just taking this example. So your API or your traditional code could be writing into any database, SQL or anywhere. But for our example, I am just writing this leave request into my SharePoint site. So in this example, where I have this leave request call, first of all, it creates a token based on client ID, client secret, and tenant ID passed for the authentication purpose. And once we get that access token out of it, then in the next call in create leave request, we are just making a call to MS Graph endpoint to create the item into my SharePoint list. So once item is success, then the leave is created successfully. So this code can be of any custom calls, any traditional APIs, whatever you are having existing. So you are having maybe like some flight booking system, then your set of APIs would be totally different. This is just for example. So this in example, we are just creating a leave request, and over here the important part is once we create this functions, so this leave request is my function, I should decorate it with this specification so that on invoking it from any LLM AI completion service, it should know that it's a native function which we want to convert that into kernel function. So this function are the key components over here, where semantic kernel coordinates function execution together with the LLM interface and allow the model to return better responses or the actions which we want to achieve. So this is the typical functions which developer wants to call via LLM. So I have just written that decorated with a kernel function and description, just precisely write the description what this function would do for you. And over here with the each argument, just try to elaborate as much you can so that our LLM would, the natural language invoking would know that what parameter we want to match it with. So I have described it. This start date would be the start date of the leave, end date would be the end date of the leave, and this would be the type of the leave, so that I can pass these prompts, and these prompts can automatically converts my input into these respective parameters. And once these parameters are passed, then I would be creating a leave request. So consider example where my user would be just writing that apply a sick leave for me from 24th November to 26th. So this is the straightforward prompt. This kernel function would be extracting these parameters out of it and then creating a leave automatically. So that's where like the intelligent automation part we are going to include into this. So now coming back to our program file, because I have already built this one and it doesn't have much detail, that's only the kernel function you should be aware about. And once I go back to my program file, here I would be again starting to invoke this method, this plugins method, so that we can create a leave request. So I'll just start again typing the kernel. So we'll just do a kernel builder.build, and before that we'll be just adding our plugin builder plugins dot add from type, and this would be in our case would be class, that is leaves class, and we'll be just registering with that name of my class itself. So it's straightforward. So once this plugins is added, then I'll just have my instance of my kernel, and in that one, first of all, we'll be just checking whether our function is getting called properly or not. So I'll just create have this kernel function instance, and I'll say apply leave, and I'll read that from kernel plugins and get function, and we'll be extracting the function from our plugin. So our plugin name was our this class, and the function name, we can go back to our the custom class which we have created. We should copy this leave request call, and it's a case sensitive, so just be sure that you are copying it properly or writing it properly. So once we have this apply leave function ready for us, we can create again the prompt execution settings, and we'll just say settings, new setting, and over here we can specify the function behavior as we did last time. So function behavior dot auto, will just do auto one, so that it should automatically check like which function to invoke, and post that will be just invoke async call to just make sure that we have registered our plugin and we were able to invoke our method properly. So we'll just say where result await kernel dot invoke async. It will take first of all this function name. So function name is apply leave, which is a function, and then it takes from kernel arguments. So kernel arguments, as we are intent to pass three arguments to our plugin. So I'll just say go back and start date, end date, and type of. So I'll just create these three variables. So right now I'll just hard code, and then we are going to invoke that from prompt. So I'll just hard code that we have created these variables. Now we'll just use kernel arguments, and again we'll be passing settings, though like this time the auto invocation is not required because we are directly like including the plugin name and we'll be just having one method, so that's fine. We have directly called this apply leave function, so which will directly call, so there is no problem. So now we are going to pass these arguments to our kernel arguments so that these can be passed to our function. So we have just added these parameters which is expected by this apply leave method. So now we are just going to write that the success or the result to our console, so that we should be knowing. So right now we just invoked our kernel function from our plugin. So let's see how it goes, and I'll just put a breakpoint into my this method which is already there, so that we should be aware that our custom traditional method or API is being called from Semantic Kernel plugin. So I'll just run it, and we are inside this leave request call, and it will grab this access token, whatever mechanism you specify. If, I mean, your API uses this OAuth, then you will be constructing the access token via OAuth or any other way. It's not about like what we are doing in this demo. It's about how you have your existing functions written. So I will just have this executed, and once it's done, it called this endpoint, that is to create the leave request, and leave request is created successfully. We can go into our leave request, and we should be seeing this item over here with the past data. So the start date we passed this one, and date and type of sick leave. So that means we are able to invoke our kernel function method from our this kernel plugins via invoke async method call. So now going back to our program file again. So this one we directly invoked to verify that everything works fine or not. But now the actual thing comes where we would be passing the prompt, and based on natural language prompt, it should extract the parameters or the details, start date, end date, and type of leave, and then do this smart operation for us for creating this leave and invoke this method for us. So I'll just comment out this one for time being, and then we are going to invoke the same method but via invoke prompt async. So I'll say result, and this time await kernel dot invoke prompt async, and over here we'll be passing the first parameter as prompt or prompt template. If in last video I told you like you can import your prompt from any prompt file, skprompt.txt file, or you can directly write it over here. So for demo I'll just write it, please apply sick leave from start date, and we'll just say the start date variable from, you can directly pass it like natural language, like start date November 15th, it should process, it should pick it, or you can pick it from your variable. So I'll just pick it from a variable to end date, but the prompt should be very much precise so that it should know that we are going to pick, this should pick the, or in the auto invocation it should pick your leave request method. So try this, end date should be of end date, and this sick leave, again I can just change that to my variable of leaf type or type of leaf. So these three parameters, and along with that we'll be passing our this new kernel argument, and this time this setting has to be passed because we'll be saying that what function behavior it should do. So in our function behavior we have written that it should auto take the function internal kernel function to do the desired operation. And over here it's always better, like if you are invoking this prompt you should explicitly pass this arguments or the parameter which that function is intended to have. Otherwise it will also work, it should also work, but your prompt has to be engineered properly so that it should invoke the right method. Otherwise we have to explicitly invoke our that leave request call. I'll tell you that in a while, and meanwhile I'll just create those parameter again. So we created those parameter again, but the important part is now this will extract these parameters, whatever input we are passing from this prompt, and will do the invocation of our method. So I'll just run it, and we again, I think we already have breakpoint, so that's fine. So we'll just invoke this one. So it called our leave request again, and in the parameter we are expecting that it should have this parameter which we are passing. So it read those parameters from the prompt which we are passing, and exactly same, and it's invoking our this traditional custom method and will create the leaf for us. And that's what we are expecting, that this import prompt async should also invoke our kernel function and do the processing for us. So we can just go back to our site and can see, like, because we haven't changed the value, so it should have two records now with the same data. So that's fine, that's a business logic, I would say. So but the core content was like how you can make your existing application smart by creating this kernel functions or the plugins, invoking plugins. So as an user provides this information, and your application should auto invoke methods so that it can call the right set of methods for you. I can go back to my program file, and I was saying that you can decide, you can, instead of auto, you can enforce like which method should be called. So you can just say required, and over here in required you can write this apply leave function. So in this invocation behavior, in the function choice behavior, it will enforce to call this apply leave instead of like looking for the auto invocation. So that's how you can specify how your kernel function should be called using these kernel plugins, how you can register. It's a very straightforward way of making your applications or traditional applications smart, intelligent with these prompts or plugins. And in the next video we are going to talk about planner, so that we can chain all these functions together to make much more complex operations. So for example, like this calling applying the leave, and then reducing the leave balance, and then notifying the approvers. So these chaining of functions should happen, and should happen using the semantic kernel, this auto invocation stuff. Let's wait for that video, and if you have any questions, please do drop your comments. I'll be happy to answer. Thank you.